Hello friends, welcome you in my YouTube channel. I am Dr. Mohammad Sirajul Faizi, Assistant Professor, Department of Chemistry, LS College, Muzaffarpur. Today in this video, I am going to talk about cyclic ketones. What is cyclic ketones? A cyclic ketone is a molecule in which a carbonyl carbon occupies a position between two other carbon in a ring structure. Look at these molecules. These molecules have 5-member ring with CO and 6-member ring with CO. We call it cyclopentanone. This is cyclohexanone. Hexa because 6 carbon is there, penta because 5 carbon is there. So cyclic ketones are named in a manner similar to that for cyclic alcohols, starting with the cycloalkane name that correspond to the number of carbon atoms in the ring. A structure chain replace the E at the end of the cycloalkane name with 1. So cyclopentane, just remove E and add 1. Now, frequently encounter aldehyde and ketones. We call it formaldehyde. Methanol is quite toxic, however it is frequently used because of its ability to kill virus, fungi and bacteria. It is used to disinfect the sterilized equipment. Formaldehyde will react with other compounds and chemically bond multiple molecules together into polymers. Polymers are molecules composed of multiple repeated subunits. The polymers that are formed using formaldehyde as linking agents are used to make plastics and adhesive, and for binding plywood. Formaldehyde linked polymers may outgas formaldehyde in airing process. Therefore, it is important to use safety precautions when handling these materials. In 2011, the US National Toxicology Program categorized formaldehyde as known to be a human carcinogen. Now, another very important compound is ethanol or acetaldehyde. Has a sweet aroma. It is narcotic if taken in large enough amounts. It occurs in smaller quantities naturally in coffee, bread and ripe fruits. Essentially or especially in apples, it is used in widespread in industries, notably in the formations of polymer adhesives such as carpenter's glue, also known as white glue or Elmer glue. I will discuss acetaldehyde biological significance later. Now, acetone, you know very well. We called it propanone. Is often used as a solvent and cleaning agent. It has the ability to dissolve many organic compounds and is also miscible with water. It is used as household nail polish remover. Acetone has a high vapor pressure and is highly flammable. It is not significantly toxic and is not currently regarded as a carcinogens and mutagenic chemicals. Friends, now I am going to talk about the properties of aldehyde and ketones. You know that aldehyde, you know the ketones. Now, what is the properties of aldehydes and ketones? Water solubility of aldehydes and ketones. A smaller aldehyde and ketones molecules have significant water solubility because of their ability to interact with water through hydrogen bonding and dipole-dipole interactions. As per nonpolar parts get larger, the solubilities of aldehyde and ketone decreases. Look at this table: ethanol, propanol, butanol, and pentanol. You see miscible 16, 17, 1, and boiling point is increasing. Now propanol to butanol, 3 to pentanol, miscible, you see, and boiling point 56, 80, 102. So boiling point is increasing. Now boiling point of aldehyde and ketones, as their nonpolar parts get larger, the boiling point of aldehyde and ketones increases because of increasing London forces. I repeat, as their nonpolar part get larger, the boiling point of aldehyde and ketones increases because of increasing London forces. So boiling point of aldehyde and ketones, look at butane, propanol, and propanone and propanol. You see which one is highest, 97, alcohol, and which one is lowest, alkane. Aldehyde and ketones have higher boiling point than hydrocarbons of similar size because of their ability to interact with each other through dipole-dipole interactions. Aldehyde and ketones have lower boiling point than alcohols or carboxylic acid of similar size because aldehyde and ketones are not capable of interacting with each other through hydrogen bond. Although aldehyde and ketones do have lone pair of electrons on their oxygen atom, they do not contain hydrogen bond to and nitrogen, oxygen, or fluorine that would be needed for hydrogen bonding with other. Now, reactions involving alcohols, aldehyde, and ketones. Reactions of alcohols, the dehydrations of alcohols. Now look at this hydrogen, 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 hydrogen. You have this OH and H, and if you dehydrate, then alkene will form. Now dehydration of alcohols, you look at here, alkene is formed. You see, alkene is forming. Now 2-propanol give these products, and 2-propanol, you see this product. So when asymmetric 2 degree or 3 degree alcohols undergo dehydration reaction, there are two different alkene molecules produced. 2 degree 3D alcohol are asymmetric when the alkyl group bonded to the carbon carrying the OH are not identical. An example of asymmetric alcohol is a 2-butanol shown here. So look at this double bond and look at this double bond. Huge difference, two different alkene are produced. Now which one is good? You have previously learned that hydrations of symmetry alkene does not produce equal amounts of both alcohol produced. A similar situation occurs for the dehydration of alcohols. For example, in dehydrations of 1-butanol, about 4 times as much 2-butene major product and 1-butene minor product is produced. It is possible to predict the major and minor product for the dehydrations of an alcohol. In the major product, the double bond is formed between the carbon that was carrying the OH and the adjacent carbon that originally carried fewer hydrogens. So the minor product is formed between the carbon that was carrying the OH and adjacent carbon that originally carried out more hydrogens. So look at this minor product, 1-butene, the double bond is formed less often between the carbon that is carrying OH and adjacent carbon that originally carried more hydrogen atom. And this is major product 2-butene. So again, this is the minor product 1-butene and this is the major product 2-butene. So in the formations of major alkene product, the adjacent carbon that originally contains fewer hydrogens will lose another hydrogen when double bonds is formed. An easy way to remember the alcohol dehydrations rule for the major product is the old saying, the poor get poorer. The poor get poorer. The poor get poorer when the hydrogens atom present represent money. Now you see, you do your work, which one is minor product and which one is major product. Reactions of alcohol, the oxidations of alcohol, and oxidation only occurs when it is accompanied by reductions. Friend, hope this video will be helpful to you. If you like this video, then subscribe my channel. Thanks for watching.